A new solution to the traffic management system for autonomous vehicles, a work developed by Rodrigo Novaes, Daniel Santos, Gabriel Santiago, and advised by Dr. Sandro Dias from Federal Center of Technological Education of Minas Gerais, Brazil. In this demonstration, participants will explore a creative simulation of an autonomous vehicle network. With the recent advances in automation fields, with the promises of Internet of Things, the possibility of using intercommunication between vehicles to improve the traffic system is closer to reality. Therefore, we have a large-scale multi-agent system, which agents are the autonomous vehicles and the devices associated to the functionality of this network. This work has as main objective the creation of a new agent, a managing unit on streets intersections, aiming to reduce the number of unnecessary stops and waits in front of a traffic light. This approach adopted the game Grand Theft Auto San Andreas together with its well-known modification San Andreas Multiplayer as a simulation environment. This decision was based on the various resources and structures the environment provides, such as the 3D objects available in the game and the possibility of modifying their predefined behavior. The first step was to choose one of the cities available in the game map. Then, we adopted Blueberry, a small-sized virtual city. To determine the paths of the vehicles over the city, we created a structure called a node. A node is composed by a unique identifier, three special coordinates, x, y, and z, that establish the position a car can occupy in the three-dimensional space, and for references that set up the connection to other nodes. The nodes were distributed throughout Blueberry, allowing us to track the traffic ways and build a car route along the city. We used random nodes as start points to each vehicle in the simulations. With this methodology, we could determine the best road based on the distance between nodes, using Dijkstra's algorithm for shortest path. This algorithm uses a start vertex of a connected graph and returns a route with minimal cost to every other vertex of the same graph. With the routes determined to each vehicle, we directed the traffic flow to the intersections, where we created functions to precisely measure the waiting time for each agent. The managing unit at intersections, that we called as Automatic Central, is an important agent of our system. Our proposal is to abolish the use of traffic lights, a node approach to solve the problem of conflict between roads on intersections, guaranteeing more safety and efficiency in the traffic. This device is projected with a special position, a queue structure, and two transparent spherical areas. These areas represent, respectively, the sign range of a central and a critical area, where there is a high probability of occurring collisions. With this information, we can use the first area to start the message exchanges between vehicles and centrals. Then, we created a protocol that establishes the operations of each agent within these areas, ensuring safety and efficiency on each vehicle's route. The protocol is defined as follows. First, the car sends a message with its identifier and destination lane. Then, the central stores the car's information in the queue. When the car enters the critical area, the central verifies if its ID is the same as the first vehicle in the queue. If it is, then its speed is increased. Otherwise, we make a series of collision verifications using the destinations informed by each vehicle, so that we determine if we need to decrease this agent's speed or if it can cross the intersection safely. As we couldn't guarantee the safety of the vehicles beyond the intersections, we created an algorithm to prevent collisions in these situations. This algorithm uses data relative to the vehicle's dimensions and its spatial position, creating a transparent spherical area tangent to the agent's position that simulates a proximity sensor. The agent checks the presence of other vehicles within this area, and if one or more of them drive in the same traffic way, its speed will be decreased to prevent a possible collision. Our initial results present a gain in our approach. In a simulation using 45 vehicles, we effectively reduced the total waiting time for each agent. We made the comparison implementing a cycle routine in the central, allowing the axis to determine the streets in a specific period of time, simulating the behavior of traffic lights. We'd like to thank Federal Center of Technological Education for watching this demonstration. We look forward to meet you.